Okay guys, in this video lesson we're going to introduce chapter 4, which talks about forces. In our previous unit we talked a lot about how things move, how do they accelerate, how do they move, change direction, what's their velocities, those kind of things. And now we're going to get into the why. Okay, so we went from how are they moving to now why do they do that. So why do we get them to accelerate? Why do we change velocity? Why can we change position? Those kind of things. Okay, and to do that we got to start talking about Newton a lot. Okay, so Isaac Newton is one of our forefathers of physics, and he did a lot of work with forces and basically explaining the motion behind the things that we see happening in our everyday life. Okay, so here we go. First thing we want to talk about is what is a force. Okay, so probably one of the most foundational pieces of physics. Okay, like literally the most important thing of the entire year is understanding what a force is. All right. So, simply stated, a force is a push or pull on an object. If I take any object and I push it one direction, or I pull it one direction, or I move it, I have to put a force on that object. Okay? It's not like, Star Wars where the force, kind of, because if you use the force, you can make things move. I guess it's kind of an analogy that might work there a little bit. But think about it. Anytime that we push or pull an object, we generate a force. Okay? Now, there are two types of forces that we have. We have things called contact forces, and then we have things called field forces, okay? Your contact forces are any time that you are making physical contact with an object, making it move, okay? So for example, I just have a couple board markers here. You know what? I'm moving them around, I'm putting forces on these board markers, and I'm using it by using my hands, making contact with it. Okay? When you push a desk across a room, when you tackle somebody in football, when you spike a volleyball, when you throw a shot put, when you play the keys on a piano, those are all contact forces that you are creating, okay? Field forces are a little bit less obvious to us, okay? Field forces, we're going to experience them most likely by using magnetism, okay? So field forces are when you actually create some sort of magnetic field or electronic field that causes movement because of that force, okay? So I have here's a little bit of a magnet. These are neodymium magnets. They're pretty strong. And if I take this, they can hold this scissors pretty well. So they're creating a force right here that keeps the scissors from falling down. Okay? This is actually a field force. Now it's in contact with it, but if I move the scissors away and you watch, that force was generated before it made contact. Okay? Another example, I have a little battery here. And if I just hold my hand here and put this above it, eventually that battery will fly up and attach to that, okay? That's a field force. So it's a force that comes from a magnetic field that causes an attraction or a repulsion, okay? So if we have two different magnets pushing away from each other, they actually can repel each other also by force, okay? Now, forces are measured in a unit called newtons, all right? Honoring Sir Isaac Newton, who did a lot of work on this field, okay? The quantifiable amount for a newton, to give us a perspective, it's the force needed to accelerate 1 kilogram at 1 meter per second, okay? So if we had a kilogram mass and we were accelerating it at 1 meter per second, we'd be generating 1 newton of force every second, okay? So our label for that, if we take a look here, newtons are kilograms times meters per seconds squared, because that's our acceleration, okay? This becomes useful for us because when we start doing some calculations, if we're trying to cancel out our units and we're measuring things in newtons, sometimes it's useful to actually cross out the n and write this in instead, and it allows us to line up our units and cancel out our units, okay? Now, newtons is a measure of weight in the SI system. That may seem kind of funny to you, but really, when we talk about our weight in our world, like, what's my weight? Okay, so I weigh 240 pounds. That's how much I weigh in pounds, okay? So the empirical system, the measure for forces are pounds, okay? That's the amount of gravitational pull pulling on me, creating my weight in pounds. In the SI system, I would weigh a certain number of newtons. That would be the gravitational pull on me in the SI system, okay? So if I'm 240 pounds, that's a lot of newtons I am, okay? So we're going to start by doing a quick little calculation, okay? So take your weight, okay? What is your weight in pounds? So if you weigh, let's say 100 pounds, okay? I don't think any of us weigh 100 pounds, but if you weigh 100 pounds, your weight in newtons would be 445 newtons. That's how much you would weigh, okay? Me, I weigh 240 pounds, so 240 times 4.45, and that will tell me how much my weight is in newtons, okay? So I'm closer to 1,000 newtons is my weight, okay? I would highlight, bold, italicize this. I would make a poster out of it, put it up in your wall in your room. I would make this like in the background of your cell phone so you see it every single day of your life during physics, because this concept that newtons is a weight in the SI system is something that you will have to deal with the entire year of physics, okay? I promise you that. This concept will not go away from this moment on, okay? Newtons is a measure of weight in the SI system because weight is a force, okay?